Hi guys, here's our lesson on piecewise functions if you need to see it again or if you were absent. Okay, so first things first, what is a piecewise function? A piecewise takes more than one function and graphs it on the same grid given restrictions on the domain. So here's what I mean by that. If you look at your function, you have f of x equals negative x if x is less than 0. And you have f of x equals x if x is greater than or equal to 0. So we have two functions. We have negative x if x is less than 0, and we have x if x is greater than or equal to 0. So we have two scenarios based upon your x, if it's less than 0 or if it's greater than or equal to 0. That 0, which I'm going to circle in green, that represents a boundary. So I'm going to go ahead and graph my boundary. Okay, so that means one function goes up until 0, and then the other function is on the other side of 0. So my blue one was the negative x, and that was if x was less than 0, so that's everything to the left. So this side is going to be negative x, and then everything greater than or equal to 0 is on the right side of my boundary, so that's going to be this side. Okay, so we're going to graph two functions. Now, to be able to graph both of these, we need to know our slope. So if you look at the one in blue, your slope is negative 1, because that's the number that's in front of x. And then for the one in pink, your slope is a positive 1, because again, that's the number in front of x. So to figure out where to start, you always want to plug in your boundary into your function. So if I take 0 and plug it into my negative x, that gives me 0. Now if you look at your boundary, it says that it's less than, for x is less than 0, which means 0 is not included. So when I plot that point, it's going to be an open circle, since it's less than 0, not less than or equal to 0. Now your slope for this is negative 1, which means normally I would start at that point and go down 1 over 1, down 1 over 1, down 1 over 1. However, your blue line should only be in the region over here. That's what the boundary is for. So instead of going down 1 over 1, I need to go in the opposite direction. So I'm going up 1 to the left 1. And there is your blue function. For the pink one, again, I want to figure out where to start on the boundary. So if I take 0 and plug it into my function, well, that's just going to give me 0. This one was if x was greater than or equal to 0, so I can go ahead and fill that in for the pink. And then your slope is 1, so I'm going to go up 1 over 1, up 1 over 1. And then you can go ahead and sketch your graph. Okay, now looking at your graph to answer the question, it says, which function did you just graph? Well, our v-shaped function is the absolute value function, so we graph the absolute value function. All right, for the next portion, we want to actually evaluate our piecewise function. So we want to find f of 17, which means we want to plug in 17 for x. Now you have to pay attention to what you have in your parentheses, because if you recall, we have two scenarios. Either x was less than 0 or x was greater than or equal to 0. Well, since 17 is greater than or equal to 0, you're going to use the one that I have circled in pink. So f of 17 is going to equal 17 because I'm plugging in 17 in for that x. And there's your solution. So you have to pay attention to what you're plugging in and which function you're going to plug into based upon your restrictions. All right, let's graph another one. So you have two functions. It's negative 5 if x is less than negative 4, or 1/4 x minus 2 if x is greater than negative 4. So once again, those negative 4s represent your boundary. So I'm going to just draw my boundary line at negative 4. And then for x is less than negative 4, that's on the left side of your boundary line, which was negative 5. And then on the right side, for x is greater than or equal to negative 4, that's the function 1/4 x minus 2. So that means my blue function is going to take up this side, and my pink function is going to take up this entire side. So we need to figure out where we're going to land on the boundary line. So if I take my negative 4 and plug it in to your function, well, there's nowhere to plug in an x, so that means no matter what you plug in, you're going to get negative 5. So I'm going to go to negative 5 on my boundary line. Now it was less than negative 4, not or equal to, which means you're going to have an open circle. So 1, 2, 3, 4, 5, open circle. And since there is no x and it's just a constant, that's just going to be a horizontal line. So there is your blue function. For the pink function, we need to figure out where this function is going to land on the boundary. So I'm going to go ahead and take negative 4 and plug it in. So that gives me 1/4 times negative 4 minus 2. Well, 1/4 of negative 4 is negative 1 minus 2 is negative 3. So that means on my boundary, I'm going to go down to negative 3. 1, 2, 3. This one is a closed circle because if you look at your inequality, it's greater than or equal to. Now to graph the rest of the line, we have to pay attention to our slope. Your slope for this is 1/4, which means from that point, I'm going to go up 1 over 4. Up 1 over 4. And then we can go ahead and graph the line. Now to find the function, I'm finding f of negative 10. So you need to see where this negative 10 fits in your scenarios over here. So negative 10 is less than negative 4, which means we are going to use our blue function. So I have f of negative 10 equals, now again, since that doesn't have an x, it's just going to end up equaling negative 5 since there's nowhere to plug in the x and it's a constant function. Another piecewise, again, as you can see, I like to color coordinate. So I have x if x is greater than or equal to 1, and I have 2x minus 1 if x is less than 1. So your boundary is at 1. So I'm going to go ahead and draw my boundary line. Now your first function, x, is if x is greater than or equal to 1, so that is everything to the right of your boundary. So our blue function is actually going to be on the right side, and our pink function is going to be on the left side. Not sure why I put a negative there. So 2x minus 1. Okay, so I'll start with the blue one. Again, to figure out where I'm going to land on the boundary, I'm going to take my boundary and plug it in. So if I take 1 and plug it in for x, I'm at 1. If you look at your inequality, it's greater than or equal to, which means you're going to have a closed circle. So I'm going to start at 1, closed circle. My slope for this function is a 1, since that's the number in front of x. So from that point, I'm going to go up 1 over 1, up 1 over 1. And then that takes care of the right-hand side of my graph. For my pink one, again, I need to see where I'm going to land on that boundary. So I'm going to plug in my boundary in for x. So that gives me 2 times 1 minus 1. Well, 2 times 1 is 2. Minus 1 is 1. And this is for x is less than 1, so it's going to be an open circle. So on my boundary, open circle at 1, and it looks weird since we've already graphed the blue one, but just bear with me. Your slope for this is 2. So from that point, normally I would go up 2 over 1, up 2 over 1, but I'm graphing on the wrong side of the boundary, so I need to go in the opposite direction. So I'm going to go down 2 to the left 1, down 2 to the left 1, and then you can go ahead and graph. Now this one we're evaluating two functions. We're evaluating f of 9 and f of negative 13. Well, f of 9 is greater than or equal to 9 is greater than or equal to 1, so that means we're going to plug that into the blue function. So f of 9 is going to equal just 9. And then for negative 13 is less than 1, so I'm going to plug that into the pink function. So f of negative 13 equals 2 times negative 13 minus 1. 2 times negative 13 is negative 26, minus 1 is negative 27. All right, letter D. Letter D, we have 3 pieces, so the process is still the same. I'm going to go ahead and color coordinate. It's negative 2 if x is less than negative 2. It is negative x plus 3 if x is in between negative 2 and 2. And it is 3 if x is greater than 2. So if you notice, we actually have 2 boundaries because we have 3 pieces. You have one boundary at negative 2. You have another boundary at positive 2. So I'm going to go ahead and graph both of those. Negative 2 and positive 2. Okay, so my blue one is if x is less than negative 2, so that's to the left of negative 2. So my blue function was negative 2. My pink function is in between negative 2 and positive 2, so that's this part over here. So negative x plus 3. And my purple is for greater than 2, so that's this portion of, that's on the right-hand side of your boundary. So, again, I need to figure out where I'm going to land on the boundary. So I'm taking this negative 2, plugging it in for your function. Well, if I take negative 2 and plug it in, there's nowhere to plug in an x, so that means it's a constant function. So I'm going to have my point at negative 2. Open circle because it was not or equal to. And constant to the left. Okay. For the middle portion of your piecewise, we have 2 boundaries. So I'm going to take negative 2 and plug it in for x. I'm also going to take positive 2 and plug it in for x. Because again, I need to see where I'm going to land on that boundary. So I have negative of negative 2 plus 3. That gives me 2 plus 3, which is 5. So on my negative 2 boundary, I'm going to be up at 5. This is a closed circle because if you look at your inequality, it was less than or equal to. So up at 5. And then I need to take positive 2 and plug that in. So I have negative of positive 2 plus 3. That gives me negative 2 plus 3, which is positive 1. So that means on my second boundary, I'm up at 1. But if you look at your inequality, there's no line underneath it, so that's going to be an open circle. And then I can go ahead and connect those dots, and that gives you your middle piece. And then for the purple, again, it's a constant function, so then on that boundary, I'm going to be up at 3. This one is closed because of the or equal to. So 1, 2, 3, closed. Constant functions are always horizontal lines. So there is your graph. Now we have 3 different functions we want to evaluate. So negative 4, 0, and 7. So negative 4, look at your scenarios. That matches your first function. 0 matches your second function since 0 is in between negative 2 and 2. And 7 matches the third one. So negative 4, I'm going to plug into the blue function. That's going to always give me an output of negative 2, since there's nowhere to plug in an x. For f of 0, I'm going to plug into the pink one. Negative 0 plus 3, well, 0 plus 3 is just 3. And then for my 7, I'm going to plug into the purple. And that's just going to give me 3, again, since you have nowhere to plug in x and it's just a constant function. Alright, our last graph. 3 pieces. Here's my blue. So this one's going to be in pink. And this one's going to be in purple. Our boundaries are at negative 3 and positive 2. 1, 2, 3. Positive 2. Okay, so for x is less than negative 3, that's my constant function of negative 5. For in between negative 3 and 2, that is my pink function of negative x plus 4. And then for my purple function that's greater than 2, that's going to be 3x minus 2. Alright, So my constant function is going to hit at -5 at -3 on the boundary. Open circle because of the inequality. Constant functions are always horizontal lines. For my pink, I need to figure out where it's going to hit in the boundary, so I'm taking -3 and plugging it in, and 2 and plugging it in. So if I take -3 and plug it in, that's negative of -3 is a +3, plus 4 gives me 7. And if you look at the inequality, that would be a closed circle, so I'm going to go up at 7. 1, 2, 3, 4, 5, 6, 7. This one doesn't actually fit on the graph, but that's okay. And then on the second boundary, I'm plugging in 2, so I have negative of 2 plus 4. That gives me -2 plus 4, which is 2. So on my second boundary, and this one's an open circle because of the inequality, I'm going to be at 2. And then we can go ahead and connect those dots and draw the line. And then finally for the purple, I need to see where it's going to hit on the boundary. So I'm taking 2 and plugging it in for x. So I have 3 times 2 minus 2. 3 times 2 is 6, minus 2 is 4. So on my boundary, I'm going to be up at 4. 1, 2, 3, 4. Closed because of your inequality. Now to graph the rest of it, I need to know my slope. My slope for this was 3. So from this point, I'm going to go up 3 over 1. 1, 2, 3 over 1. This one doesn't fit on the graph either, but that's okay. And those are your 3 pieces. To evaluate, again, pay attention to your x. For -25, that fits your first scenario. -1 fits your second scenario, since -1 is in between -3 and 2. And 65 fits your last scenario, since 65 is greater than or equal to 2. There we go. So the -25 I'm going to plug into my blue function. So f of -25 just gives me -5 because it's a constant function. F of -1 I'm going to plug into the pink. That gives me negative of -1 plus 4. And that gives me 5, because that's 1 plus 4, which is 5. And then finally, for f of 65, when I plug that in, I have 3 times 65 minus 2. 3 times 65 minus 2 is 195 minus 2, which is 193. All right. Okay, so that takes care of our example on graphing. Our second example was on writing equations. So now this one, I am giving you the piecewise graph, and we need to write the function. So we have to pay attention to where our boundaries are. So your boundary for this is at -2. Boundary on this side is at +3. So we always write our piecewise functions going from left to right. So our first scenario is going to be if x is less than or equal to -2, and this one was less than or equal to because your circle was closed. Our second portion is going to be if x is in between -2 and 3. Now at 3, it's closed, so I'm going to go ahead and change this to or equal to. And our last one is if x is greater than +3 for the boundary. This is going to be my blue function, pink, and purple. Now if you look, all of these are constant functions. They're horizontal lines, so you're just looking at where they are vertically. So this blue one is up at 1, 2, 3, 4, 5. So that means your function is 5 if x is less than or equal to -2. Pink one is up at 1. And your purple one is down at -3. And there is your piecewise function. So f of x equals that. For letter B, our boundary is at -2. So we have two inequalities if x is less than -2 and if x is greater than -2. Now pay attention to where you had the open circles and the closed circles. This one was closed and it was less than -2, or sorry, that one was open, so that's going to stay as x is less than -2. And then this one is closed, so for the greater than -2, that needs to be greater than or equal to. Color coordinating, my blue one is a constant function, so just see where it's at vertically, 1, 2, 3, so that's at -3. And then for this one in pink, it is a diagonal line, which means we need to pay attention to our slope and our y-intercept. Your graph starts at 0 and then goes up 1 over 1, up 1 over 1. So your equation for that is just going to be 1x, or just x. And there's your inequality. So f of x equals -3 if x is less than -2, and x if x is greater than or equal to -2. And for the last one, I have a boundary at -2 and one at 1. So I have if x is less than -2, if x is in between -2 and 1, and if x is greater than 1. If you notice, I didn't pay attention to the or equal to's yet. So for my first function, my first piece is the closed, so that needs to be an or equal to. This one's open on the first boundary, so that one's going to stay as a less than. This one's going to be an or equal to because it's closed. And then that one's just going to stay as x is greater than 1 because this one was an open circle. Okay. So for the first one, it is a constant function, so I am up at 1, 2, 3, 4. So that equals 4. For my middle piece, it is a diagonal line, so my y-intercept is at -1, and then from there I'm going down 2 over 1 to get my next point. So that means my equation is -2x minus 1, because again your y-intercept was -1, your slope you were going down 2 over 1. And then finally for the purple piece, it is a constant function and you're down at -5. And there is your function. Alright, so this video is a little longer than some of the other lessons just because there were a lot of examples to go through, but I hope that helps you understand the lesson a little bit better. Have a great day!